Yesterday we were discussing about the DOS attack, right? And how this type of attack can be detected, and whatever is the data which are lost, right? Maybe for a particular or specific duration. So how that can be recovered. So that we were discussing, right? At the initial phase, we discussed that we can have the detection against this type of attack using maybe some AI or ML based algorithms, and we discussed that considering few parameters we can calculate, we can take different types of classifiers or the algorithms, and we can do the detection part. Now, I also told you that instead of using the randomized search method for the segregation of data, what percentage of data we considered for training, and how much percentage of data we considered for testing. So instead of that, we can go for chronological search, right? In that case, we can split the our entire data into from a point such that the earlier part of the data that will be in training, and the remaining that will go in testing, right? That we have discussed. And then once we do that, you can do the training, and you can have the, let's say, starting from second column to second last column, you can have the score, the training time, detection time, and all, right? That you can calculate. Now, we also discussed that just to improve the detection accuracy, instead of going for the earlier part, right, this table, what we did is that we have divided the entire data set, let's say it is 38,000 something, into say some segments. Each segment contains 1,000 packets. You can consider different 700, 800, 500 also, right? It is up to, this is just a case study. And then you have the, let's say in each segment you have the some data, and you can take some statistical features of that data. Let's say if I consider first segment, then I can consider, let's say, 5 statistical features, let's say mean, standard deviation, and so on, right? You can consider, and you can calculate it. Same way for all segments, you can calculate that whatever statistical features you have considered, and all those you can give it in the training of the earlier this models, right? We have considered 9 models, right? You can consider more also, less also, depends. And then once you do that, you can go for the calculation of ranking. Now, why the ranking is required? That is one thing, right? Ranking, it has a simple formula. In the numerator you have the F1 part, which you have calculated here, right, for each classifier, so that you can consider. And in the denominator you have the detection time, so that is also you have calculated here, right, for each classifier. And some part, some tau, some parameter, so that you do not get the divisible by 0 error, maybe some 10 raised to 6 or whatever you. Now the thing is that why there is a need for calculation of this rank, right? So this rank is required just to improve the your detection part. So what you are doing, you are going to calculate the rank for each segment. Let's say in this segment you have, let's say, some data, 1,000 data, 1,000 packets are there. You calculate, let's say, statistical features is a single one, right? Let's say 5 features you have considered statistical, 5 values you obtain. Along with that, you also have some earlier whatever the features you have considered, right, which we have considered, right, from PCA. And after that you calculate the rank for each segment, right, for each classifier. So here you can see I have just shown one for each classifier. You can see that there is a rank, right? And once you have that, you can give it to some let's say some classifier, meta classifier. Here we have considered support vector machine. You can consider some other also, SVM, RVM, and so on. So once you do that, then the model which you have trained, that will act as a base model. So whenever, let's say, you considered, you calculate all these things. Now after 1 month or 2 months, let's say you acquired another data, you do the same process, and whatever you have calculated, right, earlier one with reference to base model, you calculate, let's say you have calculated rank, whatever the, let's say, this classifier has highest rank, for example, right, first one, it can be anything. So whenever you get new data, you again calculate the rank and compare with earlier 9 models which has a highest rank. So it is going to fit with only one which has the highest rank. So that particular value you have to consider, and if that value is within this, let's say you calculate some ratio, right? We can call it Concert drift, which is a ratio of the Euclidean distance between the same classifier and the different classifier. And if this value is greater than, let's say, greater than 1, then let's say whatever classifier you have considered 1 month ago, the same classifier you can go, because it is giving the highest ranked value, right, or the Euclidean distance is within certain limit. If this is not satisfied, if your ratio is less than 1, then that means whatever classifier you have considered earlier, now that is not giving the best result. So you have to, there is a retraining is required, and again you need to find out of, let's say, 9, 10, 15, whatever classifier you have considered, which one is now going to give you the best result. So it is, you can say, sort of adaptive kind of thing, that instead of going only for single classifier which gives you highest DOS detection, DOS attack detection accuracy, you can go for the adaptive one, and you have to continuously calculate, okay, after this time or after this many period of time, which classifier is going to give you the best accuracy. Uh-huh. No, here you are giving all, right? Yeah, all. Whatever segmentation you have done. So you have, earlier we have seen that after PCA, whatever features are there, right, plus these statistical features, both you are giving, right, along with that. Okay, so we also discussed that if you do that process, then obviously for certain classifiers you will get some accuracy and F1 score, right? So that you can obtain it. So this I have shown here. You can also see that how many correct predictions the classifier, a particular classifier has done, and how many incorrect predictions the same classifier has done. This is again the test one, right? It is not the accurate. Now the thing is that how to reconstruct, right, those let's say 10-second or 5-second data that was not available, missing, right? So then how to reconstruct that? So for reconstruction part, let's say as a case study, I have used this TCN. It is temporal convolution network, that I have used, right? Yeah, you can use anything else like LSTM and so many other things. So now if you wish to let's say reconstruct the phasors, right, which were not available, though PMU is sending, but at PDC end it was not available. So for example, let us consider the DOS attack is for a period of 10 seconds, right, for example. So obviously the model which you can take, that has to generate this much phasors, 10 second divided by the time period. Here I have considered 60 hertz. So 60 hertz one cycle, 16.66 millisecond, right? You can consider 50 hertz also. Then here you have the 0.02, and you have to generate 500 phasors like that. So this you have to, this much phasors you have to generate, right? Uh, Now let us say, here you can see in this first waveform, there is a, at PDC level, the DOS at, because of DOS attack, this much phasors for a period of, let's say, 10 seconds, that was not available. This is your voltage magnitude part. Same way you can consider the voltage magnitude and the current part, voltage magnitude and current, which is sent by PMU. So PMU is sending the correct phasors, but at PDC level you are not getting this much data, you are not getting for either voltage magnitude or current magnitude, depends, right? we can say all phasors. Now for this, let's say if you wish to reconstruct, then you have to use this technique. Like let's say we have used this, you can use any other technique, and you can consider, you can reconstruct these phasors, right? I have shown that if you have, let's say, voltage phasors, how you can reconstruct it. If you have current phasors, how you can reconstruct it. If you have, let's say, for example, the multiple DOS attacks, right? Let's say for 4 seconds, 10 seconds, 2 seconds, then those also you can reconstruct using any such type of techniques, right? You can generate that missing phasors, right, at each interval for a specific period of time. So if you use such type of technique, then you can reconstruct those data. And if you do, let's say if I use TCN technique, I have also used two other, like let's say the gated recurrent unit and LSTM. So using these three techniques, I have shown the comparison, right, in terms of mean square error, R square. R square is also one of the parameter where you can compare it, and training and prediction time. So here at the bar chart, you can see I have shown it, the window where the, let's say, the blue color, that is your the detection time, the green color, that is the reconstruction time, and red bar shows how many phasors you have reconstructed, right? It depends on the period up to which data that was not available, right? For example, the last one you can see where we have reconstructed 625 phasors, where for 10-second period the data that was not available. So the purpose of showing this bar chart is that if you add this detection time and reconstruction time, that is blue bar and green bar, right, then also, even though whatever number of phasors you need to consider from 125, 312, 625, 875, then also if you add blue and green, that remains well within, let's say, one cycle, right? 16.6 millisecond, it is lower than that. So that means whatever reconstruction you are doing, that can be done within that period of time, and again those data that will be reconstructed by PDC. So that is what you can see here. This is the formula which we have used for, let's say, mean square error and R square. So this is a very conventional formula, right? And for R square also you can use this formula for coefficient determination, that is R square, right? That you can use. Okay, now the replay attacks. Right? Earlier, what we were considering, those are based on the DOS attacks. Now let us see the replay attacks. So replay attacks, obviously we have already discussed. So I am going to skip this part because I am not going to discuss this thing. Now for replay attacks, what you have done, obviously you need to have some data, right? You need to require some data, and you have to divide it or differentiate it in some class. So we have considered two class, right? One is the, let's say, X class, another is the Y class. Y class contains your replay attack. It shows that it's a replay attack. And if you go further, let's say normal operations, all this that comes under the healthy part. Fault, that is also comes under the healthy part, because here our concern is just to differentiate between the normal or fault condition with attack condition, right? That's why. And for replay attack, let's say you can consider number of scenarios. Here I have shown 4 cases. You can consider n number of cases, and those all cases that comes under this part, right? So this attack. So if you just see the total data set, then that contains your features which we have considered earlier, right? Voltage, magnitude, current, sequence components of voltage, frequency, it depends, right? What features you can select, and plus some statistical features, let's say mean, variance, standard deviation, skewness, quarters, whatever you, right, whatever you feel that you can consider here. And if you combine these two, then that comes for feature selection, right? And once you have that, again, as I told you, you can use randomized search method, or you can use some other method just to differentiate how many percentage of data you consider for training and how many you consider for testing, right? And if you combine, then your supervised ML models that is available, and then you can go for the detection part. Okay, if you just apply, for example, right, let's say I have used the random forest KNN and support vector machine pre-classifier, then you can see I have shown here the training accuracy, testing accuracy, precision, recall F1, specificity and time. So again you can see that the time which is available for a specific classifier, let's say random forest, that is minimum, right? So same way, this is just you consider, you generate such type of data, and you can do the this type of analysis for replay attack also. I think this is all about the training means, let's say you have considered X percentage of data out of the total data, and then you train your algorithm, and then you see, okay, how it is performing. And then remaining data you consider, let's say 30%, 20%, 40%, whatever it is, and then you test it. But again, see what now I am telling you, what is the problem with all AI ML based classifiers. I have considered, let's say, some X number of data, right? For example, 38,000, 40,000. Now let's say after some time I have some other data which does not, that means patterns of those data or does not fall under the data which you have considered. Then what? Then this does not work, obviously, right? Because see, this all these techniques are based on interpolation, right? That means how you are learning. Let's say, for example, you tell your kid that, okay, this is a red color, this is white color, this is a green color. So then you give combination of red and white, then he or she can recognize, okay, this is mixed combination of red. But if you some give some different color which was not existing, right? Maybe, I don't know, right? So then uh, it is a failure. So same thing happened in this case also. Why it happens? Because our power system, if you consider the scenarios, those are extreme, different, entirely different. No one can predict. Today you have the load variation, let's say within 10%. Tomorrow it does not guarantee that it always remains within plus or minus 10%. It can be 20%, it can be 40% also. It depends, right? It depends on the weather condition, it depends on the season, it depends on load requirement, so many things, right? COVID time, peak suddenly reduces, so nobody can tell. So this is just a load variation. Same way, fault condition also no one can predict. Disturbances no one can predict. It can be anything, right? So that's why the biggest disadvantage of all such type of AI ML based algorithm, number one, that is they whatever the training you are doing, you are giving to those classifiers, it totally depends on how much variation you have considered in the total data set. Number one, right? And number two, the second issue is how you are going to implement this AI ML based algorithm on your chip, right, on your chip. I will give you after this the other lecture I start. So in that I will show you, right? It is based on smart meter. So then you can tell how to do that, right? Let's say you have done training, you have done testing, but ultimately what you have to do, you have to, let's say, deploy all those algorithms in a chip, and you have to fit it with your device, let's say IED or RTU. So whatever the command is coming through IED or RTU, that also routed through this chip. And then if something goes wrong, that chip can identify, okay, so this is not a fault or other disturbances or other thing, this is something else, like some threat. This is very difficult, right? This is known as the intrusion detection. Maybe Professor Sidhu will give you more light on that, right? Because he has some papers on intrusion detection. So this is what you need to do, right? So these two are the biggest disadvantage of AI. Simulation wise it looks fine, no issue, right? You will get 100% accuracy all the time, you can publish papers, fine. But when you go for deployment, then these two issues are very important. And that's why, in power system, nobody is allowing any type of AI or ML based algorithms. Still, if you go in conventional IED, they are using DFT based algorithm. Even they have not adopted LES also, least error square technique, right? Why DFT? because it is standard and proven for several years. Even your current IED or the IED which we were using 10, 20 years ago, it is working without any issue, right? So that is the, I think, the biggest problem with when you go for deployment, because manufacturers are not ready to accept those things, right? For all smart appliances, you can see that you will have let's say all smart devices in your home which can work on, let's say, fuzzy logic like our washing machine or oven or something else. But in power system, if you go still at 11 kV or distribution level, still we are using HRC fuses. Still we are using, at the most they have replaced 11 kV breaker with VCB, vacuum circuit breaker. But again, at there is no other replacement. Even if you go in some developed country also, still they are using those algorithms only, which are proven, because the manufacturers and the utility people and the industry people, they are not ready to accept it. Accept means, why they are not ready? Because they have a serious doubt on the, when you deploy it, how it performs, that is not sure. You can use as a backup, right? Parallel you can connect it and just observe. Now they are doing, right, in some of the substations in US, that they connect it in parallel and then they observe, okay, and then again they correct it and do the same thing. So that they are doing, right? The next one, yeah, दूसरा, no, real time you have only one algorithm. uh, 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 uh. But in real time, how you are going to apply 9 or 10 algorithms in one chip? Very difficult, right? It is very difficult. Here I have shown you, okay, you can take 9, 10, 15 algorithms, but in real time, how you are going to do that? So that's why in real time, I always suggest you go for your dedicated statistical based method, right, which can work on some formula. That is best. So if you wish to implement anything in your chip or on your processor, or then the best one is that conventional formula based algorithm. Okay, now let us see some aspects related to the distribution network. Right now, from transmission to distribution part, because distribution is entirely different than transmission, because protocols are different. Uh, though some of the discoms, they are using 61850, but still at let's say 415 or lower level, the protocols are entirely different. So if you see the our earlier system, that was radial passive system, radial system. Uh, why passive radial? Because uh, three things are very important. This system has low controllability. Controllability is very minimal, right? You cannot control, very minimal. Second, no real time monitoring of the data. That was also not there, right? Once it is radial, source is there, other side, left hand side source, right hand side load, power flows, that's all, right, in one direction only. That was our passive system. uh, and and again, third thing, that is your communication is not there, right? That means the data exchange, that is only the energy exchange is there from one side to other side. No other side energy exchange, no exchange of the data, right, both the sides. So that was missing, right, earlier. So now later on, after you digitize, right, digitize your entire network, right, smart grid, what you call, the system becomes active distribution network, we call ADN, right? And this ADN, as it is going to combine your physical system with cyber communication, information and communication part. So then there is always a threat, right? Vulnerabilities are always there. This includes in the form of advanced metering infrastructure, your IEDs, intelligent electronic devices, and at DER level. right? When you installed any DER with smart inverter, then at all three levels, right, the threats are always there. Earlier it was not there. When you do that, when you add DER, the power flow now becomes bidirectional from earlier unidirectional. The controllability, that is increased, and real time monitoring of the data, that is also there now, right? That is also there. So this is the change what we observed. Of course, there are some attacks, right? The major attacks, that is here, right? Puerto Rico. It was this was the attack on your smart metering systems. You can type in Google, you will find it, right? All the information. Some of the attacks are also there on in USA side, though they have not accepted. The last attack in our country, that was in Lucknow, right? Uh, Almost 150,000 meters, those meters were impacted. So this is also there in Google. Right? You can type it. Okay. Now, when your passive distribution network that is converted into active distribution network because of a connection of DER and other devices, smart devices, then your cyber physical distribution network looks like this, right? So you have to start from bottom, and you have to go the top one. So from the bottom side, if you see, there is a one layer which is known as physical layers. So physical layers are that layers where you connect your DERs, your battery energy storage system, right? Maybe you have loads, all types of loads, you can connect it, and they are going to acquire the data, right? Whatever data you acquire, even you can connect your conventional transformers and other devices which are already there at distribution level. So physical layers, that is the layer where you connect all the your DERs, all the other devices, all transformers, switches, all are there, right? And they are going to acquire the data, right? Using some, let's say, CTPT or sensors or whatever it is. So that is nothing but your physical layer. After that layer, the next layer comes, that is the interface layer. So interface layer is the layer where your ID comes in picture, and it is going to it is going to establish the connection between that ID itself and the smart devices which you have placed in the physical layer. For example, it is going to establish the connection. This ID is going to establish the connection between smart meter. It is going to establish the connection with DER. It is going to establish the connection with transformers also nowadays, right? Real time monitoring of transformer is also there. So that part, that is done in this layer, right? That is your interface layer. Then comes the communication layer. So communication layer usually divided in two parts, right? One is the access layer, and another is the backbone layer. So in this layer, this part, right, just above your interface layer, whatever ID which has established the connection with all these smart devices in the physical layer, it is going to transfer some of the data at small distances, right, using Wi-Fi network. Smaller distances communication, that is to be done in this layer by your IDs. The same ID can also do the larger distance communication in this layer also, right, using some other medium, usually let's say the wired medium, right, because larger distances it is preferred to go for wired medium, and smaller distances you can go for the let's say the Wi-Fi network. And after that, the next last layer comes, that is the application layer, where all your systems, let's say SCADA, uh, then you have the advanced demand management side systems or energy management system, all algorithms, or maybe your the let's say MIS system, right? All those systems that works here in this application layer. So finally, the task of the ID is to acquire the data from these physical devices and transfer it to this layer so that they can do some processing, right, and then they can take the decisions, right. This is our cyber physical system of distribution network, which was not there earlier when it was passive in nature. Huh? That comes here in communication layer, right? It can be anything, data concentrator, it can be gateway, it can be edge devices, whatever it is, right? That's why I'm not going to name it, right? Because someone we are using in our country, someone they are using, so everything comes under this region. That is your communication layer, whatever device you use. Okay, this I think we have already considered, so I am not going in that detail. We have discussed this thing. Only thing is that in that few things are important, like file transfer protocol. Those you need to learn. The object linking and embedding, that is also there. Some other IEEE protocol communication or regulations are also there, that we are not considering right here. This two we have already discussed. Okay, now let us see what are the possible attack scenarios possible at distribution level. So the first thing is, ultimately, as I told you, that your all IDs, they are going to acquire the data from physical layer and they have to give it to the application layer, where your SCADA is there, where your let's say meter information system is there, or where your energy management algorithm runs, where your any advanced demand side management or any other algorithms are there, that has to run, right? Now the thing is that when this data are collected by your smart devices, meters, smart meters or any other devices, and when it is given to this SCADA or any other applications, right? Obviously this has to be routed through some devices, obviously, right, which are available in communication layer. So at that layer you can easily have the attacks, different types of attacks. Now if you consider the what are the attacks at DER level, right? Then at DER level you have the attacks. Let's say I have considered the example of photovoltaic, right? You can consider wind energy also, you can consider the fuel cell also, you can consider biomass also, right? We have variety of DERs. Even you can consider CHP also, right, which is not here, we are not using, but the other developed countries they are using. So here if you consider, let's say, PV, then you have the, let's say, the attack that is possible, which can compromise your IED or breaker, right? It can also compromise your central controller, or maybe your PV controller, that is also there, PV converters. And these attacks are either in the form of malware or physical attack, right? Maybe you have man in the middle type of attack or denial of service attack, or maybe false data injection attack, that is also there, right? So this is all about the attack which can possible at DER level, right? Same way if you consider your battery energy storage system, because when you have solar, the battery energy storage system is must, right? So there if you consider your battery energy storage system, then it contains the controller, battery energy storage system controller, and BMS, battery management system, which is going to take the data, right? Let's say from inverters, transformers, filters, battery packs, all those data that is collected, and this data are given to the your main control center, that is at top level application. So this can be also, and ultimate task of this is what? Estimation of SOC, right? Because when you have any battery energy storage system, this is very much required, right? And this is done, let's say, by your battery management system itself, that you can do that. uh, so if you have this, then at this point also, right, when you send the data, even when your controller or BMS acquires the data, at all these points the attack that can be possible, right? Because there they are sending the data through some medium. You can have attack on electric vehicles also, because when you are connecting the vehicles, you have the your electric vehicle station equipments are there, right? And this are from backend side, they are going to have the control over that using some protocol, right? It can be protocols may vary from country to country, but it is there. So at all that points, right, here even at some other points also you have the attack that can be possible. uh, and attack that is also possible on your AMI, advanced metering infrastructure, where you are using the smart meters. So here at this side, if you consider, right, the this side where your house is there, right, and where your meters are there, so that is normally controlled by some local network, right? It is called the house area network. Then you have the data concentrator, gateway, anything on communication side, that is usually controlled by the NAN, neighborhood area network. This is one type of communication. And then finally, when you have the your utility center, where you have meter data management system or any other systems are there, there you have the WAN. So there at all these points, right, everywhere you can have the possibility of the attacks, right, at distribution level. Now let us see one case study, right, of some smart meters, that how the attack can be possible, how they are doing the attacks. Now if you before we move, let us see what is the architecture of the your advanced metering infrastructure. So here if you consider what are the components of your AMI, right, then it contains obviously the smart meter itself, that is there, right, which is there inside the house. You have the some communication infrastructure depending upon the capability and application. Then you have the head end system, that is also there. You have the meter data management system. This is normally at the utility side, right? And of course some web application where you want to do or you want to control it through your mobile app, so that is also there. So if you just look at what is the architecture of AMI, right, then it looks like this, right. Now here if you see this is in your house, right, home, where you have the all the smart devices, right, that is there. And you are using the house area network, some type of communication network, usually HAN, right, and then they are collecting the data and they are sending it for further processing. Here at this side you have some data concentrator or gateway, right, where they are going to use another type of network, which is this neighborhood area network, which is powerful than HAN, right, it is better than HAN. And then they are going to this is for one house. So similarly for here middle, they are capturing this type of data from different house or colonies, like that. And then once you have this, then they are all this data from captured throughout in the throughout the cities, that is again given to your utility control center, where your final application, that is meter data management system, that is existing, right. So this is the normal architecture of the AMI, right, that how it looks. Now just as I told you, if you just look at the house area network which is there in your home, then there are certain features, right. For example, this is a communication required for the house. It's a low bandwidth communication because you have limited number of smart devices in your house. And you can use the like Zigbee Wi-Fi or the some LoRaWAN type of network just for HAN. Similarly for NAN, you can it is powerful than the your earlier one, because they are capturing data from different colonies or societies of the houses. So there you can go for some better network, right. So that you can use it. And similarly for WAN, it is more powerful than HAN and NAN, and there you can use some fiber optic or satellite communication for transferring the data. No, no, means only one. See, communication network is single, and they are going to connect the data from your smart meter. This is this architecture which I have shown. That does not mean that we are collecting the data from all devices. It is already there. It is there in smart meters, right? So smart meter is going to collect the data. It is whatever let's say power. I think there are 23 parameters are there. Huh? But I have just shown that this may possible, right? See, right now what they are doing, your smart meter is only sending the data through HAN to here middle part, right? In-house attacks, obviously it is there. That's why I am telling that attack vectors are anywhere, right? See, at present, what is there, that you have a smart meter, they are collecting the data and sending here. In future, it may possible that you have all smart devices, all are running through communication medium and all are sending data. It may possible, right? We don't know what happens after 5 years. Nobody thought that that telephone does not work, right? So it is just a prediction that this may possible, right? Right now, what you are doing, you have only smart meter who is sending data to here. So individually from each homes, they are sending the data. That's all, right? Okay, now what are the attacks possible, right, at all levels? So here the attacks possible are the flooding attacks, then the malware type of attack, rug based station attack, man in the middle attack, denial of service, and data manipulation attack. This type of attacks that is possible where you gather the data and when you are sending the data at higher level. Now all this, whenever, now let us concentrate on smart meter only, right? Because if we do not have the other type of case study like EV and all. So if you just do the attack on smart meters, then that is going to lead the non-technical loss, right? This is a major concern for the utility. Non-technical loss means it is related to the energy consumed that is not billed. That means though I have consumed the energy, but I am not paying the bills. That is the only thing. Of course, some other issues are also there, like financial loss, cloud security issue, data security issue, reliability issue, quality issue, and so on, right? But that we are not discussing here. This can be this can be possible, right? Depend. Okay, now let us see the how this, I think I have discussed. Yeah. Now, let us see one case study where what we have done, we have considered the data from, let's say, some smart meters, right? And then we did the attack, right? So let us see how it works. So here, what we have done is that I think we have considered. Let me check whether it is there or not. Yeah. So we have some raw data, right, which let us we can take it from the, let's say, some meters. These are the timestamp, kilowatt hour, voltage, current, frequency, right, and the type of meter, right, that we have mentioned, and we have considered the time series raw electricity consumption data, right. We have gathered it. This we have gathered, I think, from Mathura and Bareilly region from May 19 to October 21, right? Once you have this data, then the next task is you have to process this data. So whatever data you have considered, right, you have to, let's say, arrange in a way, some way, right? This you can do in Excel very well, right? So that you have to do it. Once you do that, then what you have to do, what we observed, I don't know, some utility people correct, some of the data that were missing. I don't know why this data were missing. This is what we found, right? That when we gathered the data, someone's, or maybe deliberately he has deleted or she has deleted, I don't know, right? We asked and they said it is that data, this part data, that is not available. So then what we have done, we use interpolation technique, and then we just recreated those data, right? Because otherwise it is not possible to run any algorithm on that. So that we have done here, right? Okay, once you do that, then what we have done, the data which we have gathered, those data are 480 samples per day, uh, very high, right? So we want to reduce this data from 480 to 1/10 of that. So then we have resampled those data, right? Resampling, denoising, all this process we have done so that we can reduce this from, let's say, 480 samples per day to the 48 samples per day. So that we have done, right, at once we have the data. That resampling we have done in Python, right. That you can do in anywhere, MATLAB also, or some other tool also you can use it. Once we have this data, then we have created some attack, right, simple attack. So for that attack, just you can write the code. Let's say I want to create denial of service attack. So I have written some code, some function of, let's say, beta x is my data, right, which I have obtained after resampling, denoising, right. So this is my data set, and on that data set I have applied this beta factor. What is beta factor? Beta factor means you can have the logic, right. It is one means your same original data set, right, nothing is there, and when earlier one is there, that means for a specific period of time the data that was not available. So that you can easily do that. Same way for other type of data, let's say theft attack, you can write the other code, maybe multiply with your original data set with some factor alpha, and that you can vary that alpha using some random function, right. You can multiply basically your data set with some factors, maybe 1%, 10% or 90%, depends. Same way you can do for overloading. We know that overloading that can be 110%, 120%, or 130%. So with same data set, you can multiply your original data set with this overload, and you can generate that type of scenario. And then the fluctuations also you can create, and the composite, that means addition of earlier attack 1, 2, 3, 4, that also you can create. And once you do that, this looks like this, right. This is your healthy data, and this is your the data when you have performed the different 5 types of attacks which I have mentioned, right. So that you can generate it. Okay. Once you have, again, training, testing that you have to do, I am not going in that detail because we have already considered this part in earlier transmission, so I am not going in that detail. Now once you have this, I think I have to go back. Yeah. So now let's say I have the data set, right, and that data set, again, you can do divide it, and then you can train it, test it, and finally once you have done this, then you can have let's say the some parameters, whatever models you are considering. We have considered the DL model, and then some parameters, some let's say evaluation parameters you can consider, which was same as I discussed in case of transmission part. And once you have this, you can calculate again for each type of attack, right. You can calculate the accuracy and other parameters, right, that you can easily do that. Okay, this are the results, right, where you have reconstructed this data was missing, that you have reconstructed here, right. So same way you can do for other type of attack. Attack 1 was denial of service attack, so this data that was not there, that you can reconstruct here, right. Same way for other types of attack also you can have the results. You can compare with some other methods also. I think that is not required. Now the thing is, okay, this is all about just case study. Now the thing is how to deploy this, right? So as I told you, what you have to do is you have to write the code, deploy it. That means in your chip, and that chip should be connected in your smart meter, so that anything comes to the or goes away from the smart meter, that has to be processed through this chip in which you have written that this intrusion detection algorithm, right. So it is going to detect it, but detection does not, let's say, suffice your way, right. So you have to again take some action also. So intrusion detection, and then finally what action you need to do, how you are going to mitigate all those algorithm part that you have to write in chip, and then you have to connect it or deploy it inside your smart meter. So that you have to do. Once you do that, then we can say that my meter at present, right, that is the free from the any type of attack at present, right. Tomorrow we don't know if some other type of attacker, different type of attacker comes with some new attack, then again you have to update your algorithm so that it is capable to detect that part, right, physically, right, in your meters. So this is just what or and how we can just do that part in case of smart meters. Similar type of study you can also do for, let's say, your EVs, because number of EVs are there. EVs data are also available in some of the websites. If you do not have, let's say, physical data generation, you can do it using some website. You can gather the data, you can create the attack, and you can just perform such study. Similar type of study you can also do with DER also, right? Though I don't know whether utility will give the data of DER attacks. If they give, then you can have the data, you can just look at those data, and then you can develop such type of algorithm, and that algorithm should be fitted in the RTU or wherever, whatever device is connected with DER, which is acquiring the data of DER and sending to the your main command center or application center. So that also you can do at distribution level. The only problem comes in all this process, right, whether you take EV, whether you take smart meter, whether you take DER, that is the protocols. Protocols are different. For example, if you consider EV, for EV you have n number of protocols, right? Let's say Japan is following different protocol, India is following different protocol, US is following different protocol. So that issue comes, right? There is no single protocol. Now they are developing new one, right, I told you, but single protocol is not available. Same way for the other also smart meters also, you have again the series of protocols available, right? NC protocol is different, IC protocols are different, so those things are there, right? And same thing for third one also, that is also there. So that issue you are going to face it, and once you resolve that issue, then you can also carry out a case study for this type of attacks you can carry out in distribution network, right? So this is all about just a case study for a distribution network. I stop here. Any questions? No, no, we have not installed. Huh? Uh-huh. It detects the attack. It also mitigate it. So same algorithm you have to write detection and mitigation inside the chip. Both you have to do. Mitigation means if data was not available, you reconstruct it. Only those things you can do. What you can do else? What else we need to do? Nothing. We have to reconstruct the data. That's all, right? If data was not available. And if some other type of attack, then you have to that means, let's say for example, some false data in your data are manipulated, for example, then what to do? Then you have to give alarm that okay, do not consider this series of data, you replace it with some other interpolation or some other technique, the earlier data, right? That is what you can all those you can all those measures you can take, right? But again the question comes, for example, the data which you have manipulated, let's say some attacker has manipulated, right? Let's say in one packet you have, for example, you have 400 samples, and those data attacker has manipulated. Now you find your algorithm find out that this is an attack, right? You stop everything. Now what to do with those data, manipulated data, right? So that is again a debatable question, because even though you block that 400 samples, but you have to bill, right, to the consumer. Now consumer say I have not consumed anything, means my consumption is normal as usual as I am consuming every day. But anyway us time pe, let's say for that time he had or she had a gala dinner, right? So then he has consumed a huge amount of energy, then what to do? So those issues are always there when you manipulate the data, right? This is just an example, right? Maybe you have some other type of attack than some other thing, so that you have to think. There is no way possible for such type of thing. The only thing is you have to detect it, block, and wherever possible you reconstruct or stop or maybe use previous data, right, average it like that. That is what you can do. Otherwise there is no other option. Any other? No, but do you, is it possible that in control room the person who is sitting, who is capable to do all this pre-processing, all, if you tell them you do pre-processing, you do Python programming, वो बोलेगा मुझे घर जाना है भाई. If you write a code automatically and finally you create a black box, whatever data are coming, output you are getting, right? Like it is similar to ID, right? What ID is also a black box for utility, right? They are not, if something goes wrong, they are not able to repair it. They simply called, oh, GE people just come, something goes wrong. That is what you are doing, na? Utility is doing right now. So if you do that, then you can do always. If you are doing at let's say higher level, transmission level, you can always do at distribution level also. There is nothing harm. That you can always do, no issue, right? You can tell someone you develop this thing for us, they install it and then they do it. That you can do, right? And that all government organizations, they want that we they have been facilitated like this, whether it is electricity, means utility, or whether railways, all they are doing like this only. If I tell railways you run the load flow algorithm, they said, oh, what you are talking. They said you create, just generate one black box, give the algorithm, you have a data output, you can get load flow, V, angle, delta, active power, reactive power, losses, all that we will get on display. That's all. We can only monitor. So if something goes inside, they can't do anything. That facility you can always create, right? You can sign an MOU with someone and they can develop for you. That can be always possible. No, PCI is only for feature reduction. That means I have, let's say, 20 features, but 20 features are very, let's say, huge amount of data. I want to reduce it. So minimum data I can do the training, right? Where TCN is a reconstruction technique. It is not feature reduction technique. Okay, if no questions, then I stop here. Announcement. There is a tea break now. For the tea break, and we'll resume at 11:30 with